Good morning, students. Welcome back to chemistry class. Today we are going to study about Unit 1. Okay, today we are going to Unit 1. Unit 1 Basic Concepts of Chemistry and Chemical Calculation. Unit 1 Basic Concepts of Chemistry and Chemical Calculation. From this unit, today we are going to study Introduction about Chemistry and Classification of Matter. Okay. That's all today we are going to study. Take notes, listen carefully. Okay. First upon introduction about chemistry. Chemistry plays a major role in providing our needs and also help us to improve many compounds such as many compounds, fertilizers, insecticides, building materials, that's cement, steel, and polymers, okay, alloys, iron materials, okay, these are the building materials. Okay, so chemistry, it is plays a major role to provide these needs for our essential our life. Okay, so chemistry is everywhere in the world around us. Chemistry is everywhere we see around the world, chemistry is having. Okay, even our body is made up of chemicals. Our body is made up of chemicals, such as sulfuric acid, hydrochloric acid, and oxygen, carbon dioxide, and then acids, nucleic acids, proteins. These are the chemicals. Okay, biological materials are present in our body. Okay, understand? So the continuous biochemical reactions occurring in our body are responsible for human activities. Okay. Chemistry touches almost every aspect of our lives, culture, and environment. And actually, chemistry is touch almost every aspect in our life. Okay, even our body having the chemical reaction takes place, biological chemical reactions, that is metabolic reactions takes place in our body. Okay, in the main one of the reaction, we know respiration, it is one of the main reaction takes place in our body. What do you mean by respiration? When we are inhaling the oxygen gas, okay, when we are absorbing the oxygen in air, it mixed with our food, such that we are eating the food. So when we are absorbing the oxygen from air, it mixed with the food and it produce the large amount of energy. Okay, this is one of the oxidation reaction, respiration. Okay, so the chemistry plays very major role for our body. Okay, understand? And then so it is essential to understand the basic principles of chemistry in order to address the mounting challenges in our development country. Okay, we should understand the basic principles of chemistry in what a way, that is how we can know about chemistry. That is, we are going to study first upon classification of matter. What do you mean by matter? Matter is defined as anything that has mass and occupies space. Okay. If you look around yourself, that all made up of matter. Okay. So matter, what is the particles of matter? All matter is composed of atoms. Okay, if you are seeing your pencil, your pen, your book, okay, anything, all matter. These are called matter. So this all matter is composed of atoms. Understood? So in order to understand the properties of matter better, we need to classify them. We have to classify the matter. We have to classify the matter. So classification of matter, there are different ways to classify the matter. Different ways. One of the way, that is matter, we can classify it at two types. We can classify it at two types. What are the types? First one, physical classification. Second one, chemical classification. Physical classification and chemical classification. Okay, so matter we can classify two types. What are the two types? Physical classification. Secondly, chemical classification. Okay, the physical classification of matter, that means the matter can be classified as physical, means when we are observing their physical state. Okay, what are the three states of matter? We know solid, liquid and gas. What are three states of matter? Solid, maybe a solid, maybe liquid or maybe gas. Okay, this is the physical classification. So matter can be classified as two types. What are the two types? Physical classification and a chemical classification. Physical classification means the matter we can classify as three types. What are the three types? Solid, liquid and gas. And what are the example for the solid? Means solid, book, pen, and one of the important the three forms of water. What are the three forms of water? We know water is in solid. Okay, solid form, liquid form and gaseous form. Solid form means ice. Okay, ice cubes. There is the solid form of water, and liquid form, that is water, and gaseous form means water vapor. When we are boiling the water it converted to water vapor. Okay, water vapor. This is the physical classification of matter. And then what are the chemical classification of matter? What are the chemical classification of matter? The chemical classification means the matter can be classified as two types. What are the two types? As per the chemical classification, water can be classified as two types. What are the two types? Mixtures and pure substances. Mixtures and pure substances. Chemical classification, the matter can be classified as two types. What are the two types? Mixtures and pure substances. Okay. So mixture. Again, this mixture can be classified as two types. The mixtures can be classified as two types. What are the two types of mixtures? Homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. What do you mean by homogeneous mixture? Homogeneous mixture means that compounds that is in same phase. Okay, for example, what is the example for the homogeneous mixture? Salt water. Okay, when we are mixing the salt with water, we get the homogeneous layer, the same phase we get. That is the homogeneous. Heterogeneous mixture means oil in water. Best example, oil in water. Okay, in the case of homogeneous mixture means we cannot identify the salt is separate and water separate. Okay, that is in same phase. But heterogeneous means, example, oil and water. What is the example for the heterogeneous mixture? Oil and water. So when we are dissolving, when we are mixing the water with oil, we can separate the oil from water. Okay, we can uh, find out whether what is which one is the oil, which one is the water. Okay, so that is the heterogeneous. So the chemical classification means the matter can be classified as two types. What are the two types? Mixtures and pure substances. So mixture further can be classified as two types. What are the two types? Homogeneous mixture and heterogeneous mixture. Okay, and the pure substance. The pure substance again we can classify it as two types. The pure substance also we can classify it as two types. Okay, that is very important. That is elements and compounds. Pure substance we can classify it as two types, elements and compounds. Okay, element and compounds. Here, what do you mean by element? What do you mean by element? An element, it is the simplest substance. You know, element is one of the simplest substance. Okay, so an element consists of only one type of atom. Only one type of atom. Okay, so element, only one type of atom. That is, for example, we are taking copper. Copper is one of the copper, Cu. Okay, copper element, pure substance, element, only one kind of atom. Okay, and compounds means two or more metals, two or more substance, or two or more atoms combined form. That is compounds. For example, copper sulfate. That is the one of the compound. Okay, so element, in the case of element can exist as monoatomic or polyatomic units. Element can exist as monoatomic or polyatomic units. Okay, so polyatomic elements are called as molecules. Polyatomic elements are called as molecules. For example, hydrogen, H2. Okay, this is monoatomic or polyatomic. Mono means only one. Only one. Here, H2. This is the diatomic molecule. Hydrogen is the diatomic molecule. Copper, monoatomic, only one atom. Okay, copper. Gold, Au, it is also monoatomic. Understand? So the polyatomic means hydrogen, it is the we are taking it is polyatomic or diatomic. And P4 means phosphorus. Phosphorus molecule, it exists in P4. The atomicity of phosphorus is 4. What do you mean by atomicity? Atomicity means number of atoms. Number of atoms present in a molecule. That is atomicity. Okay, understand? So here phosphorus, what is the atomicity of phosphorus? 4. Because the phosphorus molecule is P4. How much number of atoms are having? 4 phosphorus atoms. So it is polyatomic unit. Polyatomic unit. And sulfur. What is the sulfur? Sulfur means sulfur exists in S8. Okay, sulfur, it exists in S8. Whether it is monoatomic or polyatomic element, it is polyatomic elements because atomicity here 8. Understood? These are about the elements. So element means one type of atom, only one type of atom, that is called element. Okay, so element means only one type of elements we can classify as two types. What are the two types? Monoatomic unit and polyatomic unit. Monoatomic unit, what is the example for the monoatomic unit? Gold and copper. Okay, polyatomic unit example: hydrogen H2, phosphorus P4, sulfur H2, oxygen O2. Okay, and chlorine Cl2. These are the polyatomic units. Understood about elements? Okay, then we are going to study about compound. What do you mean by compound? Compounds are made up of molecules. Compounds are made up of molecules which contain two or more atoms of different element. Compound means it is made up of molecules which contain two or more atoms of different elements. For example, carbon dioxide, CO2. CO2. Okay, CO2 means it is one of the compound. So compound means two or more atoms of different element. Two or more atoms of different element combined to form the compound. Okay, understood? So CO2, it is otherwise we call as molecule. CO2 we can otherwise call as molecule. Understood? Glucose, C6H12O6 is one of the compound. Otherwise we call as the molecule also. Hydrogen sulfide, H2S. Sodium chloride, NaCl. These are the compounds. Okay. So what do you mean by compound? The compounds are made up of molecules which contain two or more atoms of different elements. So if we consider NaCl means Na and Cl, two different elements combined to form the compound. Okay, otherwise the sodium chloride also we called as the molecule also. Sodium chloride molecule, H2S molecule, water molecule, H2O. Otherwise we called as the compound also. Okay, so molecule, what is the difference between molecule and a compound? What is the difference between molecule and a compound? Molecule means in a molecule, the atom can be two or more same kind of atom or different kind of atom combined to form a molecule. Two or more same kind of atom or different kind of atom combined to form a molecule. That is called a molecule. For example, hydrogen, H2 molecule, same kind of atom combined here. CO2, different kind of atom combined here. These are the molecule. Okay, but compound, it is all compounds are not molecule. Sorry, not all the molecules are not compound. All the molecules are not compound, but all the compounds are molecules. Okay, all the compounds we can say as molecule. Okay, but all the molecules we cannot say as compound because molecules are maybe same kind of atom or different kind of atom, but a compound only different kind of atom combined to form the compound. So hydrogen, H2, we cannot say that is compound. Sulfur, S8, we cannot say that is compound. Phosphorus, P4, we cannot say that is compound. There is only molecule. Understood? I hope all of you understood about molecule and a compound. And then we are going to study about properties of compound. Properties of compound. The properties of compounds are different from those of their constituent elements. Properties of compounds are different from those of their constituent elements. Okay, so for example, sodium chloride. We are taking one of the compound, sodium chloride. Here, sodium is a shiny metal. Chlorine is an irritating gas. Okay, sodium is a shiny metal, but chlorine is an irritating gas. But the compound formed from these two elements, sodium chloride, shows different characteristics as it is a crystalline solid. Okay, crystalline solid. Sodium chloride, we know this is the common salt. What is the name of common salt? Sodium chloride. Important for the 1 mark question. What is the name of common salt? Sodium chloride is one of the common salt. Okay, but it is in compound, that is the different property, but it is in elemental form, it is different property. Okay, so when Na sodium 2Na plus Cl2 compared to form a 2NaCl. Okay, so the molecular form, the property is different here. This is the physical property different. Physical property, it is in a crystalline solid, sodium chloride. Okay, but here in the elemental form, sodium, it is in white, it is in shiny metal. It is one of the metal form. Sodium, it is solid metal form. Okay, chlorine, it is irritating gaseous form. Okay, when sodium combines with the chlorine, it is the crystalline solid. These are about the compounds. Understood? Okay, students, these are about the atom. Means you know about the atom. It is the smallest particle of any element. Okay, so element, it is consist of only one type of atom, or element can exist as monatomic or polyatomic units. Okay, the polyatomic elements we call as the molecules. Okay, so the gold, silver, this is the monatomic molecule. Au, Cu, copper, there is the monatomic molecule. We say it is an atom. But polyatomic molecule, we can say as the molecule. Understood? These are about the classification of matter. Very, very important. Classification of matter, we can classify as physical classification and chemical classification. Physical classification, that is solid, liquid or gas. Chemical classification, again we can classify as mixtures and pure substance. The mixtures means homogeneous and heterogeneous. Pure substance means elements and compound. Okay, okay, we can conclude this session, because I have to mark the book back question. Unit 4 book back question I have to mark, and everyone should you should try to write the page number 4 and evaluate yourself. Okay, by applying the knowledge of chemical classification, classify each of the following into elements, compounds or mixtures. Okay, try to write the eight chemical substances are here: sugar, seawater, distilled water, carbon dioxide, copper wire, table salt, silver plate, naphthalene balls. Try to write whether it is element or compound or a mixture. Okay, elements or compounds or mixture, have to write. And tomorrow we will study about that atomic mass and molecular mass. Tomorrow we will study. Okay, students, today your assignment, unit 4. Okay, unit 4 you have to study, because coming days you are going to write the midterm examination. Okay, so easy to write the midterm examination. Have to study the unit number 4, hydrogen compounds. Okay, so here with 2 questions I will give to write the to study and write the assignment. What are the 2 questions? First question, question number 22, explain why hydrogen is not placed with the halogen in the periodic table. And the second question, write the chemical equation for the following reaction. First, reaction with the hydrogen, with reaction of hydrogen with the tungsten oxide on heating. Second one, hydrogen gas and chlorine gas. Okay, these 2 questions you have to study and write the assignment and send me through my WhatsApp number. Okay, so remember, you should write the assignment and separate note, and have to take notes in YouTube class. From YouTube class, in that same note you have to write the assignment and notes. Okay, one side of the note have to write the assignment, and the back side, other side of the note have to write that notes. Okay, from the YouTube class. And the classwork note, you should write the separate note. Understood? Okay, now we are going to mark the question answer, remaining question answer. All of you take page number 123. Today I will mark 10 questions. Okay, 29 to 38. Okay, 10 questions I will mark today. So the 29th question, do you think that heavy water can be used for drinking purpose? Do you think that heavy water can be used for drinking purpose? That is in your note having, not in book. So the first point, the chemical reactions shown by water and heavy water are nearly identical. Okay, chemical reaction of the water and heavy water are nearly identical. However, what is the second point? However, due to differences in masses of hydrogen, differences in masses. Okay, the hydrogen and deuterium difference mass. Okay, deuterium is heavy than hydrogen. Deuterium atomic mass 1, atomic mass 2, but the hydrogen atomic mass only 1. Okay, so however, due to differences in masses of hydrogen and deuterium, such reactions occur in different rates, different speed. Rate means speed. What's the third point? The rates of the reaction involving D2O are slower than those involving H2O. Okay, so the rates of reaction involving D2O are slow reaction than those involving H2O. What is the fourth point? If D2O is consumed, the enzyme catalyzed biochemical reaction will occur slower than their optimum rate. Okay, so the rate of the reaction here is slow when comparing heavy water. When comparing ordinary water, heavy water, the reaction will be very slow. Okay, so if D2O is consumed, if we are taking D2O, the enzyme catalyst for the biochemical reactions will occur slower than their optimum rate. Okay, the normal rate. The metabolic reaction, it is very slower than optimal rate when we are taking the D2O. Okay, so the D2O means heavy water, you know. The next point, the enzymes may then lose their ability to catalyze a biochemical reaction. Okay, so here the rate of the biochemical reaction is slow, so enzyme may lose their ability to catalyze a biochemical reaction. Okay, understood? So what is the sixth point? Thus heavy water will interfere and disturb the biological process, and hence it is not suitable for drinking purpose. Okay, and question number 30. What is water gas shift reaction? What is water gas shift reaction? Page number 103. Take page number 103. Water gas shift reaction. The carbon monoxide of the water gas can be converted to carbon dioxide by mixing the gas mixture with more steam at 400 degrees Celsius and passed over a shift converter containing iron or copper catalyst. This reaction is called as water gas shift reaction. Okay, CO plus H2O gives CO2 plus H2. So water gas shift reaction means water gas means CO plus H2O means water gas. Okay, so we are passing it can be converted by the more steam. Okay, more steam at 400 degrees Celsius, we get the carbon dioxide and hydrogen. That is the water gas shift reaction. Okay, then question number 31. Justify the position of hydrogen in the periodic table. Page number 101. So here, the hydrogen has the electronic configuration of 1s1, which resembles with ns1 general valence shell configuration of alkali metals. Okay, so hydrogen, you know, atomic number 1, so electronic configuration 1s1. Okay, which resemble with ns1 general valence shell configuration alkali metals, you know, lithium, sodium, potassium, rubidium, cesium. These alkali metals also, what is the general valence shell configuration? ns1 configuration. So here similarity shows. Understood? And then point number 1. It forms unipositive ion. What is the question here? Justify the position of hydrogen in the periodic table. Hydrogen, which place occupy hydrogen? The first group, first element in the periodic table, hydrogen. Why it is position there? Because of the reason we are studying now. Okay, so the first point, it forms unipositive ion like alkali metals. The hydrogen can form unipositive ion like alkali metal. Alkali metal, you know, sodium, potassium, cesium, and the outermost electron, only one electrons are present in the outermost orbit, so it easily remove the one electron to form the uni means one. Okay, one positive ion. Like hydrogen also only one electron, so it can easily lose this one electron to form H+, that is proton. Understood? So this is the one of the reason. And it forms halides, oxides, peroxides and sulfides like alkali metal. Alkali metal can form halides, there is a sodium halide. When sodium combined with the halide, that sodium halide, sodium oxide, when combined with the oxygen to form sodium oxide. Okay, and peroxide, sodium peroxide, and sulfide, sodium sulfide. Okay, like that hydrogen also can form halides, oxides, that is water. Okay, hydrogen when combines with the oxygen to form water. and when it combines with the O2 to form hydrogen peroxide, it is compared to oxygen to form water. Okay, so to compare to hydrogen to form hydrogen sulfide. Okay, like the alkali metal. This is the another one reason. And third point, it is also acts as a reducing agent. Hydrogen also acts as a reducing agent like alkali metals. Okay, this is the question number 101. Justify the position of hydrogen in the periodic table. This is the reason for the position of hydrogen in the position occupy the first place in the periodic table. And one more points here. One more point having the right side of the page in this line. Okay, in most of each compounds hydrogen exists in +1 oxidized state. +1 oxidized state. Okay, most of the cases hydrogen can form +1 oxidized state. Therefore it is reasonable to place the hydrogen in group 1 along with alkali metals as shown in the latest periodic table. Hydrogen, it is placed in the group 1. Understood? And next question number 32. What are isotopes? Write the names of the isotope of hydrogen. Okay, what are isotope? So what are isotope definition? Not having the book, so we have to write the note. I am written the note. So here, what are isotope? Write the names of isotope of hydrogen. You know, isotope means atoms of the same element having same atomic number but different mass number are called isotope. Okay, you know hydrogen, isotope of hydrogen, you know, protium, deuterium, tritium. Okay, so protium otherwise we call it as the hydrogen H11. Okay, deuterium means H12, so that is D12. Tritium means H13, so T13. So isotope means atoms of the same element. 3 are the same element, but same atomic number not differ here, but mass number only differ. Okay, understood? This is the isotopes of hydrogen. And next question, give the uses of heavy water. Page number 111. Page number 111. Take now. Uses of heavy water. Okay, here the 3 uses have to mark. Heavy water is widely used as the moderator in nuclear reactors as it can lower the energies of fast neutron. Second point, it is commonly used as a tracer to study organic reaction mechanisms and mechanisms of metabolic reactions. And third point, it is also used as a coolant in nuclear reactors as it absorbs the heat generated. Up to here I have to mark. Okay, and then question number 34, explain the exchange reactions of deuterium. Explain the exchange reactions of deuterium. Page number 105. 105 take now. Exchange reaction, you know, this is the exchange reaction. Deuterium can replace reversibly hydrogen in compounds either partially or completely depending upon the reaction conditions. These reactions occur in the presence of deuterium or heavy water. What is the formula? CH4 plus 2D2 gives CD4 plus 2H2 and 2NH3 plus 3D2 gives 2ND3 plus 3H2. Okay, this is the exchange reaction of deuterium. And next question, how do you convert para-hydrogen into ortho-hydrogen? How do you convert para-hydrogen into ortho-hydrogen? Page number 102. Page number 102. Here the para form can be the last 102, the last 4 lines. Okay, the para form can be catalytically transformed into ortho form using platinum or iron. Alternatively, it can also be converted by passing an electric discharge, heating above 800 degrees Celsius and mixing with paramagnetic molecules such as oxygen, NO2, or with nascent or atomic hydrogen. Okay, up to here I have to mark. And question number 36, mention the uses of deuterium. Mention the uses of deuterium. Okay, this is not in textbook. Mention the uses of deuterium. First point, heavy water. Deuterium, it is the one of the part of heavy water. Okay, heavy water is widely used as the moderator in nuclear reactor. So deuterium, it is combined with oxygen to form heavy water. So this heavy water widely used as the moderator in nuclear reactor. So this is the one use. And the second, it is commonly used as the tracer tracer to study the element reactions mechanism. Elemental reaction mechanism is true as the tracer. Okay. And third point, it is used as a coolant in nuclear reactor. You know heavy water. Heavy water is the oxide of deuterium. So it is used as the coolant in nuclear reactor. Okay. And question number 37. Question number 37. Explain preparation of hydrogen using electrolysis. Explain preparation of hydrogen using electrolysis. Page number 103. Page number 103. Electrolysis. This is the preparation of hydrogen by electrolysis. High purity hydrogen is obtained by the electrolysis of water containing traces of acid or alkali, or the electrolysis of aqueous solution of sodium hydroxide or potassium hydroxide using nickel anode and iron cathode. However, this process is not economical for large scale production. Okay, at anode, 2OH minus gives H2O plus half O2 plus 2E minus. At cathode, 2H2O plus 2E minus gives 2OH minus plus H2. So overall reaction, H2O gives H2 plus half O2. Okay, already I explained clearly in YouTube class. If you have any doubt, you can see once again. Okay, you can watch once again and study. And question number 38. Question number 38. A note. A group 1 metal A which is present in common salt, which react with B to give compound C. Okay, so here a group 1 metal A which is present in common salt it react with B to give the compound C, in which hydrogen is present in -1 oxidation state. Okay, here group 1A which is present in common salt. What is the common salt? You know, sodium chloride, NaCl is the common salt, you know. So which metal is present in the sodium chloride salt? Sodium is the metal. Okay, so metallic sodium, it reacts with B. B means when sodium it combines with the with B to give compound C, in which the hydrogen is present in -1 oxidation state. So when sodium combines with the hydrogen only, we get the sodium hydride. Sodium hydride, hydrogen is -1 oxidation state. We know, we studied clearly. Okay, so here A means sodium. Okay, B means hydrogen. When sodium combines with hydrogen to form sodium hydride, here hydrogen is -1 oxidation state. Understood? And then second reaction, B on reaction with gas C to give universal solvent. You know universal solvent mean, what is the universal solvent? You know already universal solvent, very very important for the 1 mark question. Universal solvent, water, H2O. H2O is the universal solvent. Okay, here what is the reaction? B on reaction with the gas to give universal solvent. So gas B means here hydrogen B. It reacts with how water molecule is formed when hydrogen combines with oxygen. Oxygen is the gas to form water. Okay, so what is the second reaction? Hydrogen reacts with a gas, that is oxygen, to give water, that is the D. Then what is the third reaction? The compound D on reacts with A. The compound D again react with A to give E a strong base. Okay, compound D, that is H2O. It react with A means here sodium A to give the E. E means here E is the one of the strong base, that is sodium hydroxide and hydrogen. Okay, it release the hydrogen. This is the question answer. Okay, the A means sodium, B means hydrogen, and C means sodium hydride, and D means water, and E means sodium hydroxide. Okay, up to here you have to mark. And the remaining tomorrow I will mark. Okay, thank you students. Thank you. Have to study the question number 22 and question number 26. Okay, explain why hydrogen is not placed with the halogen in the periodic table. That question, and write the chemical equation for the following reaction. Number 1, reaction of hydrogen with the tungsten oxide on heating. Second one, hydrogen gas and chlorine gas. Up to here you have to mark. Okay, thank you students. Thank you.